and it was really interesting as well. I think we had really nice also two speakers from the companies. Are there any questions? Maybe we can take one or two. We are over our time, but since people are still here, maybe. Federico.
Hello. I was wondering, as these species are kept in captivity for longer and longer, their genetic variation should decrease. And so imputation should become more and more effective and more cost effective. Is that correct?
Who are you asking the question to?
Well,
Roman?
that's
or to
Roman,
all of them?
yes, so all in general. Because if we think about like dogs, they got these very long haplotypes because they are quite inbred. And so you would imagine something like that would happen in aquaculture species, which then would make imputation much more feasible and much more cost effective.
Yeah, well, maybe I'm not going to answer the question directly, but you're right that with less diversity and in particular with less linkage disequilibrium, imputation is more easy, more cost effective. That's something we struggle for with mollusks, for example, that they have very low, linkage disequilibrium. So imputation is not very effective. So you still need a lot of SNPs, but you also don't want species with low genetic diversity, because breeding with no genetic variation is not very effective. So it's always a trade-off when you select. You want to select for the best fish, but also maintaining genetic variability. This is a key point that we do for our members, is maintaining genetic variability as much as possible. So
thank you.
Thank you.
Does anybody want to, Sig or Adrian would like to also reply?
No, I fully agree. I fully agree with Romain.
Okay, thank you, Roman. Alan, I see your hand raised as well.
Yeah, okay, I have a comment and a question. The comment is in response to the previous question. I think, yeah, if you don't control inbreeding, you're going to get decrease in genetic variation within your populations, but breeding programs should actively manage levels of inbreeding. And so you then look at the populations of other farm animals like chickens that have been under intense selection for many generations. And I would suggest that they're still seeing genetic variation, large amounts of genetic variation, because I don't think the classic model of how inbreeding delivers reduction in genetic variation works. There's new variation occurring all the time. My question was to Antti Kaus. Antti, are you proposing a scenario where we move to a next generation genomic selection which calculates breeding values based on SNPs and structural variants? So you get a like a combined prediction of the two sets of variants that allow you to then get the best of both worlds?
Well, the way it's currently done is that it's possible to use the individual SNP variation in the breeding value evaluation. That is still we are relying on the linkage of those markers to any real genes. So it's still this sort of black box approach. Of course, the next step can be that if we can add more and more DNA markers, and we would know, for example, that they are in the important regions, then there is a possibility that it would increase the accuracy and it would be more targeted selection. There has been approaches into this direction. Often they are not as successful as you might think. And the reason is that we typically have already so much markers within or across the genome that it tends to capture most of what is there. But I refer to what Sigbjörn was saying about the pan genome, for example, that if you are able to show that you are able to explain more of the heritability of the genetic variation, then it indicates that the new information what you got, it will be more effective also in the breeding program. So there are ways to go into this direction. I think this is what Sig kind of is saying. And perhaps in the future, this is then at the very far future, more we understand about the genome, then more precisely we can predict the total genetic merit of the individuals. In a way that sounds very logical, but it will be very long journey, but small steps forward.
Yeah, so my comment to this is that I really believe that structural variants are very important. I think the reason that this is not included in current breeding schemes is that they are difficult to deal with. So firstly, they are very difficult to identify because you don't find them. The majority you don't find with short read sequencing, so you simply ignore them. A lot of the structural variants are not present in a single genome, so you need to display them in pan-genome. And there's not like a very cost-effective way of genotyping them like we have today with SNPs. They are easily genotyped with array technology, and they are digital, so they are easy. The data is easy to deal with. With structural variants, they are more diverse. They are more difficult to genotype, but it doesn't mean that they are not important. So they affect by far more DNA than the SNPs, and they also function. They also affect genes and they affect phenotypes, and the future will show us that they are important. And I think that this is already shown in humans and in other species.
But we could get to a situation where if we generate that information about a group of animals, so which animals carry which structural variations, and we combine it with their genotypes for SNPs, then we get a combined breeding value that tells us more accurately what the performance of that individual's offspring will be.
Yeah, and there is also a lot of efforts now on imputing structural variants from SNP variation. So SNPs in linkage disequilibrium SVs. Yes. But it's not necessarily so that you have you're able to capture all the SV variation with SNPs. And there's also a lot of structural variants that are not in the reference genome, meaning that they are not a part of the SNP panel because the SNP panel was developed on one reference.
Okay, thank you. I think I understand it better.
Thank you, Ellen, for your comment and question.
Very good question.
Yes.
And it was at the heart of the AQUAIMPACT and AQUA-FAANG, how the two projects are linked.
I think there are no more questions. Maybe Maria, you can just share our contact information because our next webinar is on 13th of April on disease resistance and immune response. So you can follow us from our websites or social media channels. And for AQUA-FAANG, we have an emailing list, so you can subscribe directly with the QR code to be informed by email.